Got to find my notes from this week. They might not be in here. Oh, here's some.
Cool.
Did you wash your hands? Oh, good. Okay. Good job. I'm doing homework. Is that okay? Okay. Yes, I'm studying.
Okay. Let's see.
Do you have the formulas written down?
In my notes, I do. Hold up. Oh, there we go. Okay. So it wants to have in the y value that's half gt squared plus vt plus y. Yeah.
So when the projectile strikes, t is equal to. Awesome. I have, well, let's see. I'm missing my,
Just for a second.
Hey, baby. Will you pretty please go play in your room and bring me my phone back? Will you please bring my phone to me? Oh, where's my other one? Okay.
I'm gonna use 10 for gravity because the numbers are a lot nicer.
Are you sure?
I mean, we could
You said
use
9.8?
we could use 9.8. I mean, in physics terms, there's only one significant figure, so we'd use 10 anyways. And the numbers get really, really ugly. Oh, it says on the decimal places. Never mind. Darn it.
Yeah, it's okay.
That's not nice.
So time
Oh, sorry.
Sine of 6. Wait, is it 30? Yeah, it's 30.
Put it into. There we go. That makes a lot more sense. I forgot the sign. I was like, that's a big number.
Lena, what did you do with my calculator? Okay.
Okay. So I have 61.2 seconds.
Me too.
Nice.
Perfect.
I mean, we did something the same.
Yeah, it's 1 decimal place. Okay, so for the range, isn't it the velocity squared divided by 9.8?
Range, velocity squared, sine double the angle divided by 9.8.
Oh, how'd I miss that?
That's
Yeah, okay.
not accounting in the vectors, I think. Yeah, that's if you're not using your unit type. I don't. Darn it, can't see.
It's okay, I got it. Okay, so it'd be the sine of 60.
That is a lot of meters.
Oh dear.
Is it a symmetrical number?
3181. Oh yeah, 31813. I'm assuming that's what you got.
Yep. And
okay, so now we need to find how long it takes it to get to 5 kilometers.
yes. So plug 5 into the x equation because it's downrange.
So 5,000 divided by v cosine theta, right?
5,000? What?
Well, because it's 5 kilometers.
Oh, 5 kilometers. I had 5 meters. Okay. Units.
Oh, sorry, sweetheart. Okay, 600.
That makes a lot more sense.
Hi, sweetie.
What'd you get for your time first?
9.6225. Is that what you got?
Yep. We'll choose to round it to there just so we're consistent between each other. Rounding is hard.
Okay, and then
We plug that back in.
it's gonna be. Am I close to the door? Yeah, it's okay. It's okay, sweetheart. You know, honey, it's okay. Did you get 233?
Hmm?
Great. Mm-hmm.
Did you square the time when you multiplied it by gravity?
Yes.
Okay.
Wait, did we not get the same thing? What did you get?
2433.
Yeah, that's what I got.
Oh, I thought I heard 100 instead of 1,000. Okay. Like, never mind then.
And yeah. Oh, Alina. Oh, will you pick up my notebook, please? That was not very nice.
So I want to use the velocity equation this time because we want when the velocity is 0 in the y direction.
Thank you, sweetie. I need the paper. Sheldon, can you help me here? It just started from, yeah. Will you pick that up for me, please? Yeah, she threw it off my lap. I just need to pick that up. All of it. Thank you. I got a number, but I think it's too high.
How high is it?
459. No, 4,591.
What was your time?
Let me see. I did not do it right. Okay, so you're gonna take the y and take the derivative of it, right?
Or you can have, so velocity equation is, velocity is the initial velocity times sine theta, sine alpha minus gt. Oh, that's just the derivative. Okay.
Wait. V naught sine alpha.
So 300 sine 30 minus 9.8 t.
Oh, yeah. Okay. And that's what we're setting equal to 0.
Yep.
So t is going to be V naught sine theta or alpha over 9.8. Okay. Okay, so time is equal to 30 seconds, 30.612. Is that what you got for your time?
No, I got 15.3.
15.3?
I'll
It's
try that again.
600.
Maybe I did it wrong. 300.
600 times the sine of 30 degrees, right?
Divided
Which
by
is 1/2.
9.8.
So 300 divided by 9.8.
Wait, sine of 30 was 1/2, you said?
Yes.
Wouldn't it be 150 divided by 9.8 then? If you're not are you accounting for the half when you're doing your equation for counting for time? Because your time's about double 9. 300 times 1/2 divided by 9.8.
So are we just assuming that the highest is in the middle? I mean, it should be. So is that why?
Not necessarily.
Okay, why mathematically did we put an extra half in there?
You don't have the initial half in front of the 9.8 because that's when you would take the derivative of the initial position equation. 2 in the square would cancel that out.
Right. So where's
it's just minus GT.
That's what I have.
Times sine of 30 degrees divided by 9.8.
Yes.
Which is 15.3.
Maybe you should show me your work, because I feel like I have exactly what you're saying, but I am still double what you have.
Okay. I had to do some errands. No, not that one. Darn it. Oh, stop. Come on, computer. Don't do this to me.
I'm sorry. I'm making this difficult.
Oh, I'm on York typing that. That's not fair.
I suppose I could just show you mine and you could tell me why it's wrong.
I almost have mine up.
Okay.
I just have to tell Google Hangouts to use a different window. There we go. So I have 0 is 30 sine 30, 300 sine 30 minus 9.8 t.
Okay, why do you have 300? Isn't the initial velocity 600?
That is what I did wrong. Thank you.
Oh, okay. So there isn't an extra 1/2. You just thought it was 300.
Yes.
Okay.
That would do it.
I was so confused. Okay.
That sounds like me. I believe it.
Whew. That was confusing.
And then plugged in.
So yeah, it's a pretty high number. Like 1,000's number. But I guess it is going 31,000 meters.
Yeah.
So I guess it's okay if it goes up 4,500.
So yeah, 4591, right?
Yeah, but rounded to 92. 4591.8.
The total range, or yeah, it would make sense for this 30 degrees is almost to 45, so it'll be a little bit less than the potential for, I mean, the projectile strikes 30,000 meters away. We
Yeah.
get about an amount of that. That makes sense. Okay, next question. This value isn't too unreasonable.
Find the curve's unit tangent vector. Okay, so for this one, don't we find, so we take the derivative of each component, right?
Yep.
And then
you get the magnitude of the derivative.
And then divide it by the magnitude of it?
Yep.
Okay. What did you get for your magnitude?
I got 21. Or 21 t squared, darn it. That goes away.
Yeah, but I think the t squareds all cancel because it's divided by, right?
Yeah, the t squareds cancel. I forgot that part. And oh wait.
3,
I accidentally did it right. Okay.
Good job.
I put the wrong thing on the paper, but the right thing in the when I translated it. So I'll call that a win.
Ah, why is it being weird?
Computers are being weird today.
Acting like it's turning it in, which I am not prepared for.
Oh. That's not okay.
No.
And then what have you gotten length yet?
No, not yet. So yours is 6/7, 2/7, and -3/7, right?
Yep.
Okay, cool. Now the length would be the integral, correct?
The integral of the magnitude r prime t. Because it's dr dt over dt dx, or ds dt. I had it upside down in my notes. So the derivative of the function that gives us length is on the bottom, and is the magnitude of r prime of t. So we just integrate that. So it's integral of 21t squared. Darn it. That does change things. No.
Wouldn't it just be the first thing then? Or no?
No, because we took the magnitude before we changed things. So it's only one number instead of three. We got rid of the components by taking the magnitude. We integrate the magnitude part.
We integrate just the magnitude?
Yes.
Okay. So
I'm not the best at explaining things, sorry.
no, you're good. So it'd be 7t cubed is what we're doing it. From 3 to 1? Or am I wrong?
Mm-hmm. Yes. Or you're right, not wrong.
Okay. You got 182?
Yep.
Awesome. Yeah, okay, I don't get the last one.
The question 3?
Yeah.
Okay.
I did the reading, I really did, but
Let's see.
I didn't quite understand it. One of them is dotted and one of them is crossed.
Okay, so t is what we just found. That's the unit tangent vector.
Okay. N is the normal vector.
Which is the tangent vector times the inverse of the curvature. The curvature is the tangent vector over the magnitude again.
Wait, does he not have reading for this? He does.
I copied on a table in the notes. I believe there's reading for this, at least what I'm looking at in my notes.
Okay. Well, I can find the tangent vector since that's first, right?
Yep.
So ugh. Why does it have to be so complicated?
I know, it's the worst.
Oh, okay, actually it's not that bad. Well, okay,
Yep.
it's not that great either.
Do you have things that cancel in yours, for chance? Just to make it simpler.
Not really. I do have a negative 6 sine t and a positive 6 sine t, but the second one is multiplied with 6t cosine t.
You should chain rule that to get to the thing. So it'd be negative 6 cos t plus 6 sine t. When you just chain rule or product rule the 6t cos t.
Yeah, that's what I did.
And the second one, I think Because it starts with a -6 in the original equation, you can cancel out, just like you did in the first one. In the first half.
Wait, well, how did that cancel when?
So derivative of 6 sine t is 6 cos t. And then the first part of the product rule is -6 cos t as well. So the 6 and the -6 can of the cos.
Oh, okay. I'm forgetting that they're added together for the product, or yeah, for the product rule, not multiplied together. So yes, they do cancel out.
Awesome. I'm not crazy, thank goodness.
No. Okay, so the I component is 6t cosine t, correct?
Yes.
Okay, and the J is is it a positive or a -6t sine t?
Positive.
Okay. Magnitude is Did you get 6t for the magnitude?
Yes.
Oh, I did it right. This is so fun when I actually do things right.
I know, it's the best.
So that would mean it's just cosine t plus sine t. Right?
Yes.
Because the
Or
6 is
cosine
canceled.
comma sine t. In different vector now.
Oh, wait. Yeah. Yeah. Okay. Now the normal vector.
So you'd want to do the curvature first, because the normal vector requires curvature, from what I see. Oh wait, no, it doesn't.
And that's what.
It does not. I am just incorrect.
What is n equal to?
Sorry, it's derivative of t over the derivative of the magnitude of t.
So would it be, are we talking big T here, the one we just found?
Yes, big T.
Okay, so the derivative of t, which is negative sine t cosine t, divided by
the magnitude of that derivative.
Oh, the magnitude of that derivative, which was?
Which would be like 1, because it's sines and coses. Square root of negative sine t squared plus cos t squared.
Okay, so we don't want to use the magnitude that we found in the last one.
No, that would give you the curvature.
Good call. Okay. So it's just the same. It's just the derivative then.
Yep.
And then the last one is the curvature.
Yep. Which is t prime over magnitude of r prime.
And that was the 6t.
Mm-hmm. Wait. Why are you not in vector? What?
Where did you get all these? Were these from the video?
I didn't get it from the video. I got it from the document on due date 1. The TNB frame notes from due date 1.
Okay.
That was in the TNB frame and curvature section.
Cool. Oh, yeah, I'm definitely looking at the wrong thing.
Did I copy this down wrong? Why is this only one value? Wait. Something's not right. Something isn't adding up.
Okay. I can look at the TNB frame and curvature.
Yep.
Yeah, no, you've got it. It's T prime, T, and R. That is too small for me to read. Just a second.
Is it the magnitude of all of that? Is it supposed to give us one value?
The magnitude is on the bottom. So, would it just be negative sine t over 6t?
Shouldn't there be 2 values though? Unless I'm super confused.
Well, yeah. So negative sine t over 6t, and then the other value is cosine t over 6t.
But there's only space to type in one answer.
Oh, that's the problem.
So before that in the table, it defined it as the magnitude of dt over ds, so the magnitude of d prime. So I wonder if it was a typo in the notes.
Maybe so, because yeah, throughout the whole table, it's all magnitude on both top and bottom until the very end.
So
I don't know.
Maybe I'll do the first part of that, the magnitude of t prime instead to find it, instead of t prime over magnitude of r prime.
So you'll just do the magnitude of t prime and then.
Which is 1, so hopefully
Which
that's
is
it.
1, so it'd be 1/6t, right? Would be the answer?
No, I mean, let me double check the table just to make sure I'm remembering things right.
Okay.
Before I go make things up. Reading. So just the first part of that in the chain of equal signs, the magnitude of dt over ds. Oh, it's a dt over ds, so it'd be so we have s from earlier. No, we don't. but we can find S by
DS?
integrating. We can find ds over dt by integrating the magnitude of r prime of t. This is maybe just a check work. I'm going to do this. If nothing else.
Go for it. I'm going to Google curvature.
That's a smarter way to do it.
No, you do what you're doing. Let me see if I can find anything helpful. It's, yeah, the magnitude of dt over ds. Which doesn't help if you don't have ds.
But we can get ds. Because that's from what we did earlier to get ds. Wait, no, we don't need to integrate that because that would just give us s. Just kidding.
Wait, which one is ds?
So ds over dt is the magnitude of r prime of t. Like it was used in the big T equation. If you follow where it shows r prime is magnitude of r prime is equivalent to ds over dt. The rate of change of the arc length of time.
Okay, so that was their magnitude at the very beginning?
Yes, the 6t.
Okay. Yeah, did we not already have that?
Yeah, we did have what?
I thought we decided that. So 6t.
Oh, wait. So looking at the, I know what I did, and I know.
I think isn't it just 1 over 6t?
So it.
Or t over 6? Because if it's the magnitude of the first one, or
Yeah.
magnitude of negative sign.
1 divided by 6t.
T being on the bottom?
Yeah.
That's right. Okay, I almost did not do that. Okay.
Yeah, that should be right, probably.
I need to write down all these things from the table.
Yeah, tables are helpful. I like tables.
Makes a lot of sense. Okay, well, should we submit it? I'm always scared to do this now.
What could possibly go wrong? Let's do it.
I don't know. At least we get a full credit for
First
participating.
One.
No
First
way.
one, we got everything right.
We got it all right. Oh no, I missed one. I must have written something down wrong.
Darn it. That's not cool. Which one?
Let me see. I still got 91%, so I'm happy.
Which question?
Oh, I didn't put a 3 at the end of the 2433. I just did 243.
Oh.
Whoops.
Those are the worst mistakes.
Oh well. I'm still happy with 91%.
Yeah.
Awesome.
Let's see.
That's the best thing ever. Okay.
Any questions from homework or anything?
I don't think so. I mean, I probably have questions about my quiz, but I haven't really looked at it, so.
Okay.
I'll just email you if I have questions.
Okay, and I'll try to respond to this time because I realized that I didn't last time.
That's okay. I figured it out, so you're all good.
Okay.
Okay, thanks.
No problem.
We'll see ya.
See ya.
Bye.